Okay, now in this lecture, we are going to proceed together to explain the side view for the cladding. We need to show the cladding system on the side view and the bracing on the side view. Let us first remember what we said in the previous lecture. We had here two bays, 12 meters and 24 meter. The 12-meter bay, we covered it using a frame, and the 24-meter bay, we covered it with a column truss frame. The roof is sloped by a slope of 1 to 10. As you can see here, we showed the levels. The level of the or the eave height of the column is 10 meter, and because we are having the slope is 1 to 10, this spacing here is 12. So 12 over 10 gives 1.2. So 10 plus 1.2 is 11.2. So the level here is 11.2. The level at this point is the same as the level at that point. The depth of the truss at its connection with the column is almost 1/10 the span. So if the span is 24, this is almost 1/10. It is 2 meters. The slope here as well is 1 to 10. So if this is 24, يبقى half of it will be 12. يبقى this means that the level of this point will be higher than the level of this point by 1.2 meter. So it will be 12.4. This is a complete typical elevation. We are showing all dimensions. We are showing all purlins. The spacing between the purlins here is 1.5. The spacing between the purlins here is 2 meters. We are having upper bracing at the top level. That's the one that we showed in the plan of the roof. Associated with the upper bracing, the vertical bracing, and the vertical bracing here, and the vertical bracing there. Okay, whenever we are having a column, there will be a vertical bracing. And of course, because this is a truss, for the frame we are having only upper bracing, but for the truss there should be upper bracing and lower bracing. We assumed last time that as if we are having a mezzanine floor, we said that we cannot have one beam like this with a span of 12 meters, otherwise it will deflect. So, or the depth of the beam will be very large, uneconomic. So it is better to provide a column in the middle to break the span. So the system here of the mezzanine floor, we are having main beam rested on the column of the frame and the column of the frame, and another intermediate column. This main beam is supporting secondary beams spaced at a distance of 2 meters, and this is supporting a metal deck RC slab. Metal deck RC slab. Okay, now our lecture is to draw the side view. We need to draw the side view, this section, section 1, and this section, section 2, and this section, section 3. When we start drawing the side view, we don't look like architects. Okay? When you are an architect, you are going to see the elevation or the column itself here, and also you are going to show the roof. But of course we don't do that. We are just showing this part, the one that is in front of us. Because if we showed all of these details, we don't get anything, or we don't gain anything out of this. And the same thing, when we are cutting here, I'm just going to show the column CD. When I'm cutting there, I'm going to show the column EF. So let me first show you the first view. Which is These are the columns. If you remember from the last lecture, these spacing were, this was 6 meters, 5 meters, and this is 6 by 6 equals 36 meters. The level here is 0.1 and the level here is 10. We gave these columns axes. So we call this axis 1, 2, 3, 4, up till axis 9. Very good. What are we going to see for the cladding system first? We said before that we are having the brick wall is up till level 3 meter. And up till here we are having corrugated sheet. So this part is covered with corrugated sheet. The corrugated sheet cannot span a distance of 7 meters. Okay? Therefore, I'm going to have side purlins, and these side purlins will be located every 1.75. So I'm going to show here. This is the end of the wall. And this is the roof purlin. We divided this into 3 equal spaces like that. 4 equal spaces, I'm sorry, this is 1.75, and the cladding system here is corrugated sheet. The cladding system here is brick wall. Also, we are having vertical bracing. Let us see. Let me explain this. I need to elaborate on this column. Okay? This column is like that. This is the central line of the column, like this. We are having here the roof purlins, and this is the corrugated sheet. And here we are having the side purlins like that. And here we are having the corrugated sheet. And after that we are having the brick wall. We said before at this intersection, we are going to put the rain gutter. And the rain gutter, we are having the downspout. Okay? So this is our view of the column. Take care. At this level, in the center, we are having the bracing system. So we are having here the gusset plate for the bracing, and also take care that we are having a beam here for the mezzanine floor, so we are having the bracing. So the bracing is found at the level of the middle of the column, but the side purlins are attached to the column from the outside. So if you cut a section here like this, to see how this column look like, this is the column. Attached to the column from the outside, the purlins. These are the purlins. And the purlins, they are supporting the corrugated sheets. Okay, of the cover. And in the center, we are having here the gusset plate that is connecting the vertical bracing. Okay, so this is the side purlin, and this is the vertical bracing. Okay. Now, if we look at perspective view for this case, here we are having our frame is like this. If we took a perspective view, then the frame is like that. And we said before that we are having here the roof purlins, and here we are having the upper bracing, and at this level as well we are having the bracing that is found in the level of the mezzanine floor. Now, where does this upper bracing send or transfer the reaction? The reaction will be transferred at this point and will be transferred at this point. And also this horizontal bracing will transfer the reaction here like that. Therefore, this frame will take a load at this point and will take a load at this point, right? These 2 points here, they are associated with the presence of the horizontal bracing. Because we are having upper bracing, there will be an out of plane force, and here I will have an out of plane force. Therefore, on the other side here, let us draw at this level we are having a force associated with the upper bracing, and at this level we are having a force that is associated with the horizontal bracing that is found in the mezzanine. This reaction is obtained from this bracing, and this reaction is obtained from this bracing. As you can see here, this horizontal bracing will transfer a load in the out of plane direction, and this horizontal bracing will transfer a load to the column in the out of plane direction. These two forces, if I call this force 1 and this is force 2, this is force 1 that is caused by the upper bracing, and this is force 2 that is caused by the bracing of the mezzanine. Now let me ask you a question. I want to establish here this distance is 6 meters and this distance here is 10 meters. Okay? I want to establish a stable truss that will take these two reactions and transfer them to the support of the column. How can I do this? Again, one student might think that he or she will do a system like this. Okay? This is wrong. Although the angle theta is between 30 and 60. What's wrong about it? It did not respect the force 2. Whenever you are having a force, you cannot have a force applied in the middle of the member. There should be a joint. Therefore, here I should have a member, and here I should have a member. Now, this distance here is 4 meters because we know that this is 6 and this is 10, and this is 4, and this is 0.1 and this is 6. Let us say that this is 6 meters. So this is 6 and 6. The angle is perfect, 45 degrees. So the angle theta is acceptable. And this is 4 and this is 6. Also the angle is not bad. So I can have the system like that. One more thing, there is a bracing normal to the board. I have to indicate here the presence of the upper bracing at this level and the presence of the bracing with the mezzanine floor at that level. Is this enough? Of course, we have to have a bracing in the beginning and a bracing at the end and in the middle, and as we drew before in our lectures. But remember, I cannot do this. Why? Because here this member will continue definitely. Let me compare between this column and any other intermediate column here. What is the difference? Now, when you get a plastic ruler like that and you apply a load on it, what will happen? When you apply the load, the plastic ruler will buckle like that. But what if you hold the plastic ruler in the middle and you applied a force like this? After a while, or when the load increases to a certain value, it will buckle like that. Which one is stronger? If the same plastic ruler and the same length, the only difference is that you provided a support in the middle. This one will fail at a load of 10, but this one will fail at a load of 40. 4 times as much. Okay? Why? Because now you reduced the buckling length. You changed the way it will buckle. Instead of single half or half sine wave, now it buckled as a full sine wave like that. يبقى therefore, this column is braced because of the presence of this member and this member. It will buckle like this. And the same thing for that column. But this one is not as such, يبقى therefore it will buckle like this. يبقى it is expected that I will change the cross section of the column. This column can be smaller in size because its capacity is very large because we are providing a bracing system in the middle. But this column is not braced in the middle, it will buckle with the full length of 10 meters, then I will have to enlarge the size of the column. It's not convenient to go to the same hole and you find that the size of the columns is different. And therefore, we should provide a bracing throughout the members like that. يبقى this strut or this bracing system should continue throughout the hole. And I will provide vertical bracing here, vertical bracing there, and vertical bracing in the middle. And I should indicate the presence of the upper bracing and the bracing at the level of the mezzanine. This is axis 6, 7, and 8. So this is a complete view. Take care. Instead of drawing a side view showing the bracing system alone and a side view showing the cladding system alone, I did something in between. This left-hand side is showing the cladding, and that's why, as if I am cutting like that. In the left-hand side, I am looking to the column from the outside. So I will only see the purlins. I will not see the bracing behind it. And after that, in the right-hand side, as if we removed the purlins and I am looking to what's found behind it. This means that if you are standing outside the hole, you will not see anything except the corrugated sheet and the brick wall. And when you go inside, you will see the column and you will see the bracing system and you will see the purlins from behind the corrugated sheet because you will be standing here. So you should be able to see the column, the bracing and the purlins, and then the corrugated sheet from behind. Okay? يبقى this is a view showing the cladding system and showing the transversal wind bracing for section 1, which is the column AB. Okay? Let us show after that if I took another section and I want to see the column CD. Okay? Well, this is section 1. Okay, we don't have cladding here. Maybe the system of cladding we are having brick wall, or we are having gypsum board, or maybe there is a handrail and we are having here brick wall in this part. So there is no special cladding. It does not require any kind of side purlins. All what we have is the vertical bracing. Therefore, there is no such a thing as cladding system anymore. I will have to indicate the spacing. This is 6 meters, this is 5 meters, and this is 6 by 6. The level here is 0.1. Take care that this column is connected to the beam, which is at level 6, and then is connected to the bottom chord, which is at a level of 9.2 and 11.2. So we are having level 6 and we are having level 9.2 and level 11.2. Okay, and these are the columns. Okay. Now, because we are having a bracing here, there will be an out of plane force, as we explained before, coming to the column at this level. And because of the lower bracing, there will be an out of plane coming to the column at this level and another one coming to the column at that level. Therefore, I will have, this is upper bracing, this is the R upper, and this is R lower, and here we are having the reaction coming from the mezzanine floor. How am I going to construct a truss here? These distances, again, this is 6 meters or 5.9, and this is 3 and okay, and this is 3.2, and here we are having 2 meters. Okay, the spacing here is 6 meters. So I will have to put a member here and a member there. Very good. How am I going to construct my system or my trusses? I have to use triangles. مش كده؟ I have to use triangles. This distance is 6 and this distance is 2. If you used a cross, the angle will not be that good. Then we are using a K truss. Now this angle is better because this distance is 3 meters and this distance is 2. You will find that the angle is very good. It is between between 30 and 60 degrees. The same thing. Here you are having 3.2 and here you are having 6 meters. Again, I am going to have a K truss. And this is 6 and 6. Excuse me for the scale. Then I can use a bracing. It will be ideal because the angle will be 45 degrees. Of course, this will have to be repeated. I will have to indicate that we are having upper bracing, lower bracing, and a bracing with the level of the mezzanine. And I will continue that like this. And we are having a bracing system after axis 5. Whenever we are having horizontal bracing, there should be vertical bracing. And also at the end, we should also have bracing like that. This will be section. This will be section 2. Okay? This is the side view. Because we took side view for the column AB, we have to show the cladding where we are focused on the purlins, how they are spaced, the type of cladding material. This is corrugated sheet and this is brick wall. And then as if we removed the cladding for the other part of the section, we are showing the transversal bracing and the indication of the upper and mezzanine bracing. And here we don't have cladding because this is the area between the two holes. We don't have cladding system. The cladding system, for example, is a brick wall or something that does not require the use of purlins. We are just putting our bracing, and the bracing, of course, should be consistent in the same base like that. The last section will be section number 3. We are looking here, so we are going to see the cladding and we are going to see the bracing. Okay, let us remove that. So now we are going to draw together section 3. Okay, in section 3, first we are drawing the columns. Again, they are spaced at, this is 6 meters and 5 meters, and this is 6 by 6. We are having the levels here. This is 11.2, and this is 0.1, okay? And we are having the level of the brick wall is at level 3 meters. So we are having here up to this level plus 3 meters. Up till this point, I am going to show the cladding. And here I'm going to show the transversal wind bracing in the rest of the section. Okay? Right. For the cladding, we are having a purlin just above the brick wall, and we are having a purlin at the end. So we are having a purlin here, and we are having a purlin there. This distance is 8.2 meters. We cannot have the spacing between the purlins 8.2. Again, it is from 1 to 2 meters. We decided in the previous lecture to take constant spacing of 1.75, and the last distance will be 1.2. So we are going to follow this here. So if you would like to write here, this is 3 meters, and this is 1.2, and this is 4 by 1.75. Okay? The cladding system is composed of corrugated sheet, and the cladding system is composed of brick wall. Of course, this should continue, but in order to save our effort, instead of drawing a section or a side view illustrating the cladding and another side view illustrating the bracing, we are drawing both at the same time. This part is the cladding and the other part is the bracing. For the bracing, let us see, where do we have the upper bracing and the lower bracing? We are having upper bracing at the top, and we are having lower bracing at a distance of 2 meters. So here, this is the reaction coming from the upper, and at a distance 2 meters, we are having the reaction coming from the lower. Okay? This distance here, this is our lower, this is 2 meters, and this is 9.2. Very good. Right. We should have a member at the top to support or to be at the same level of the upper wind bracing, and there should be another member here to be in the level of the lower bracing. Again, we don't want this column to be stronger than this column. Okay? If this column is braced, I'm going to extend a strut like this. Notice that the level of the strut, this distance is 2. It has nothing to do at all with the side purlins. The side purlins, they are just located so that the spacing between the purlins is from 1 to 2. It has nothing to do with the location of the strut. The strut is located where the horizontal bracing is. Because I am having horizontal bracing here and horizontal bracing there, we located these two struts. For the purlins, it is a totally different story. The spacing between the purlins is from 1 to 2 meters, so we selected the spacing as such. So not necessarily that this member will be at the same level of that member. Okay. طيب, let us arrange the bracing. Again, this distance is 6 meters. Okay, so this is 6 and this is 2. If you take a cross like this, the angle will be very bad. It should be from 30 to 60. Therefore, I am going to use a K-truss. The K-truss is better. طيب. This length is 9.2 and this is 6 meters. If you calculated the angle, well, it will be on the edge, be almost equal to 60 or maybe more than 60 by a little bit. So why don't you relax the angle and use a member in the middle like this, so that the angle is exactly or is in the range between 30 and 60. Now, as long as you located a strut like this, this column, whenever it will buckle like that. Okay? So it is braced here. The strength of this column is very large. So you can reduce the size of this column. How about the column next to it? Now you are having a strut like this. It will be weaker because the buckling length here is bigger. I will have to extend the strut as usual. Again, not necessarily that the strut will meet at the same level of a side purlin. This is 9.2 over 2, which means that this is 4.6 meters. Okay? Now I'm having in the beginning and also in the middle and at the end. But the one in the end, I'm not going to show it because it is behind the cladding. The one in the middle will be drawn here as usual, like this. What is missing in this view? We need to indicate the presence of the horizontal bracing. Therefore, there should be horizontal bracing here and horizontal bracing here. Don't be confused. I don't have a horizontal bracing at this level. There is no horizontal bracing attached to the column at this level, only at level 9.2 and 11 and level 11.2. So this will be section 3. If you want to indicate the axes as well, you can show me the axis 1, 2, 3, so this is a complete side view or section 3, section elevation, where I am showing the bracing at one part and the cladding at the upper part. In section 2 we did not have cladding, so we just showed the bracing, and in section 1 we showed the cladding and the bracing as well. Now you should be able to solve for me your first project in the steel part, and it will be just like what I explained for you. How are you going to arrange your drawing? In AutoCAD, you will be you are going to put everything for me in the same drawing sheet, and will be drawn in the form of an AutoCAD like this. Here you are going to show your name, the university, the course, and everything, and you are supposed to write here the notes. These notes are related to the dimensions, the material properties, the loads applied, and properties of fasteners. I mean by fasteners bolts and welds, and you will also provide the design code used. If you open my notes, you will find a sample of the general notes that we are applying in the steel structure. Well, this is optional, but you should learn that whenever we're having any structural drawing, we have to give indication on the units used, the units of the level, the units of the dimension, what kind of material I'm using. I'm using steel 37 or mild steel. What kind of loads, how much of a life load I'm considering, how much of wind load I'm considering, how much of finishes, if we have the weight of the cladding material and all of that. The properties of fasteners, what type of bolts I'm using, what type of welds we are using, and also the design code that is used to design all of these elements. Okay? Then we are going to draw the plan. We are having here this is the roof plan. Okay, this distance is the 47, and this is the 24 and the 12. Okay, and then here you are going to show me this is the 24. You are going to show me here the lower wind bracing, like what we explained together. So you are not showing everything, you are not showing the 36, but as if you are cutting here, because you want to get focused on the part where we have the lower wind bracing, which is the part of the truss. And then you are going to show the other plan, which is the plan of the mezzanine. Here we are having so many members like this, and the secondary beams. Okay, so we are showing the roof plan, we are showing the plan of the lower bracing, and we are showing the plan of the mezzanine floor. And then you are going to take a section 1 and section 2. Here you are going to draw for me section 1. And then you are going to draw section 2, which is the end gable. Okay? And then you are going to take the side views that we studied today. This is section 3, section 4, and section 5. You are going to draw the sections here, section 3, section 4, and section 5. So these are the side views that we explained today. Three, 4, and 5. And this is the roof plan, okay, that we explained last time. And this is part of the plan only showing the lower bracing, and this is part of the plan only showing the mezzanine floor. We explained them last time. And here we are having, this is the typical elevation. And here we are having the end gable. يبقى this is your first project. Everything in one drawing, size A0. And you are going to submit this to me in the form of AutoCAD and PDF. I need to see the drawings arranged like this. I need to see the axes, okay, drawn in each view. The dimensions, the levels, we are not missing anything, exactly like what I explained for you. And you will draw for me the 3 side views that we explained in this lecture under each other here like this. If this is not enough, you can divide this into 2 sheets, no problem. But I want the sheet to be, I don't want it to be void. I want it to be filled with views like that, clearly showing the axes, the dimensions, the levels, and the components of the steel structure that we should follow. طيب. After that, what will be the contents of our lectures? I'm going to explain for you how to calculate the loads on the trusses and the frames. And we are going to go through the design of truss members when they are subjected to tension only, or compression only, or tension and compression in the following lectures, inshallah. Okay, thank you.